This is the dielectric function, and dielectric function means the what is the behavior of your material in the presence of light. What's your material behave in the presence of light. Dielectric function has two parts. The first is real part and the second one is the imaginary part. The real part of the dielectric function, that is also known as epsilon 1 into omega, and the imaginary part of dielectric function is also known as E2 into omega. As we discussed, when you calculate the optical properties of the material, first of all you can find the absorption of your material. When you find the optical, this is your material and the light coming fall on your material. Light, you can also know that the electrical nature, also the magnetic nature, because of photon. You can also know, and you can also familiar that your material also exhibit the electrical nature and also the magnetic nature. So in optical properties, we can ignore the magnetic behavior of the incoming radiation and also the magnetic field of the your material. We can only discuss the electronic behavior of the incoming photon and the electric field of your material. Why we ignore the magnetic behavior of our material? When we discuss the thermoelectric properties of our materials, then we can also discuss the magnetic behavior of the incoming radiation and also the magnetic behavior of our material. So in this case, we can only discuss the electronic behavior of the incoming radiation and the electronic field of our material. This is the real part of dielectric function and the imaginary part of dielectric function. The real part of dielectric function shows the scattering properties of your material. It means that the incoming light when strike of your material, when the phenomena of scattering or reflectivity occurs, then the real part of dielectric function discuss that reflectivity, and that interaction phenomena is known as the real part of dielectric function. When the incoming radiations absorb by the material, then we discuss the absorption, and the imaginary part of the dielectric function discuss that absorption when the incoming light absorbs by your material. So as I can say you that the real part of dielectric function is the scattering. As you can say that these are along x-axis, so we can discuss first of all the main part of the real part of your dielectric function. Along x-axis, basically it is the energy in terms of electron volt of the incoming radiation in which your material is exposed. Along y-axis, basically it is the behavior of your material in the presence of light, maintained energy in terms of electron volt. First of all, you can say that at zero level, it means when you did not expose your material in the presence of light, you can say that there is your materials significance. Yes, your materials also possessed some energy at probably 3 basically it has units of 3 hertz, 3 per mega electron volts. It means that your material already has some storing energy. That is also called polarization. What is polarization? Polarization means it is the unique property of your material. It is a unique property or the distinguished property of your material in which the electric field of your material, electric field in sense the unique storage of electric energy of your material. Basically, initially when you did not applying energy, when you did not expose your material in the presence of light, it means I guess I can say that suppose 3 arbitrary unit of this. Okay, you can say that arbitrary units. Where you did not know about the units, you can say the arbitrary units. I can say that at 3 your material also possess energy, suppose 3 arbitrary units. When we expose the light, your material, and you increasing the light of the suppose 0.1, 0.2, 0.2 and up to, you can say that your material's ability of the polarization increases. As increase as decrease, as increase as decrease, as increase as decrease. So the behavior of your graph increasing, decreasing, increasing, decreasing. What is the physics behind this? As your material, I can say this is your material and this is the incoming light. I explained you at 3 electrons your material has unique property of polarization. It means already it has 3 electron mode arbitrary units. It has up to 3% have the ability to store the energy already when you did not expose the material in the presence of light. When you expose your material in the presence of light, it means that your material's ability of polarization increases. How? It means that suppose the number of electrons lying here 1 2 3 4 2 3 4 lying in the same periodic pattern. As your material falls on them, suppose it means falls on the your external field, means in terms of photon, fall on the same atom and scattered back. If does not find on the same electron, absorbed in interstitial site. If target on the same atom lying on your falls on, it means that scattering occurs when the external light targeted on the atom of your material, scattered backs are reflected back. When does not strike on the same targeted atom of your atom, it means it's lying on the interstitial side. It means it absorbs of your material. When it absorbs your material, the phenomena occurs here. And when the scattered of your material, the phenomena occurs here. It means the scattering is high. So first of all, when your materials just like starting of the scattering, it means your materials lying on the same target elements bounce back. It means increasing. And then you can also increase the energy. First electric field lying on your target material, and you are also increasing 3 and 4 atoms lying on the target material. It means also increases. When it's the same increase, it means it does not fall on the target element, but also it falls on the interstitial side. It means absorption is increased. When your material falls down, it means absorption increase, and when the peaks are appeared, it means the maximum number of scattering occurs. The real part of dielectric function and the imaginary part of dielectric function has the inverse relation to each other. When the scattering is high, it also you can say that absorption is minimum. When absorption is minimum, scattering is maximum. When scattering is maximum, absorption is minimum. These two relation has inverse relation to each other. Okay. The main part of this, when your material lying exposing the zero level of your material, it means that below the reference level or the zero level, your material behaving as the metallic nature. Above this, your material is semiconductor. I can explain you. Above the zero level, I can say explain you scattering is maximum. When scattering is maximum, absorption is nothing, because when scattering is maximum, absorption is minimum. Scattering is minimum, reflection is minimum, absorption is maximum. Okay? Below the zero level, when the absorption is minimum, the maximum energy absorbed by the material, it means maximum number of electrons are increased. When the maximum number of electrons are increased in your material, it means it behaves like a metallic nature, because excess number of electrons, because the external field of the of photon is contribute to the contribution of the your material of the electric field. These two, electronic field of the external radiation and the electric field of your material, combine to each other, and the absorption is maximum, and your material from semiconducting nature to metallic nature. When you also increase the energy, so it means that absorption does not absorption occurs when your light falls does not target the material interstitial side. These dip value, it means that the targeted atom does not strike the external field, only the interstitial side present between the atom also targeted by the external field. So when also increase, it means that scattering occur. It means that the maximum light fall on the targeted atom, also targeted atom, and also you can say that below the zero level, interstitial shall increase and the maximum number of electrons increase, and the electric field of the external line constructive interference occurs to the electric field of the your material. It means below the zero level, metallic nature exhibit, above the zero level, semiconductor nature exhibits. And first of all is your material also ability to 3 electron hole, that is also called polarization. Polarization means it is the ability or unique property of the material to get store the energy in the form of electric field. Above the zero level, you can also say that the maximum reflection occur, maximum scattering occur. Below the zero level, your material becomes a metallic nature. Above the zero level, your material becomes a semiconducting nature. And the real part of dielectric function has the inverse relation to the imaginary part of dielectric function. It discusses the scattering or reflection, and it is also called the absorption of your material.
अच्छा, एक इससे छोटा सा क्वेश्चन ये है कि अगर जब हमारे पास मैक्सिमम अब्जॉर्प्शन ये वो स्कैटरिंग हो रही है तो उस समय हम क्या सीधा कह देंगे कि हमारे पास ये मटेरियल सेमीकंडक्टर में है?
आप जब स्कैटरिंग हो रही होती है ना
जी,
अब ये मटेरियल आपके स्कैटर्ड होकर पीछे जा रहा है
जी,
तो ये कुछ ना कुछ तो हमें एनर्जी सम एनर्जी इज ट्रांसफर बाय द
जी
मटेरियल.
सर,
इट मींस द व्हेन द एक्सटर्नल लाइट striking the your material, some energy is stored in your material. It means some energy is stored in the material and maximum bounce back. When energy is stored in your material, it means conducting nature to semiconducting nature. Some energy is stored, it means some electric field in terms of electrons are stored in your material. Semiconducting nature. When the maximum when the maximum number of electron, maximum electric field is stored in your material, it means that the maximum number of electron, maximum energy electrons, maximum energy levels, maximum orbitals, maximum hybridization occur. That's why maximum absorption is occur. When maximum absorption occur, it means from there that is dip, and your material becomes a metallic
ठीक है.
nature.
और अब इसमें सेमीकंडक्टर का तो हमें बिल्कुल स्कैटरिंग से पता चल गया, अब्जॉर्प्शन से हमें कंडक्टर. तो इसमें इंसुलेटर वाला कोई है, मतलब कि इंसुलेटर पे ये कैसा बिहेवियर होगा इसमें?
अब आप when band gap is above
देन
3 electron volt, your materials become a insulating nature.
insulator.
So in also the nature of the insulating material also scatter is occurring. It depends upon the external field which are applying on your material. When it depends upon the structure of your material. When the maximum external field lying on your material, it is upon the internal structure of your material, interstitial side, targeted material. You can also when your material is a conductor, insulator or semiconductor, the external field also changes the nature of your material by depending upon the external electric field and magnetic field of your nature.
Okay. ये y एक्सिस पर क्या है सर हमारे पास?
It is
the
the
energy basically.
It is the frequency or the behavior of your material in the presence of light of the external material.
energy. Okay.
अच्छा, ये स्टॉप कर निकलते फिर लेट हो रहे हैं.
मैंने बहुत